friends, this is Kruti Jaipancholi, Assistant Professor in LG Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject Microwave Engineering. In the last video, we have started learning about active and passive devices. So, we will learn about the various active components in this lecture. So, today we will learn in deep about the microwave hybrid circuits. So, this consists of the study of the various kind of the devices or the components like the directional coupler, then the circulator, waveguide T, H plane T, E plane T, okay, magic T, then after the hybrid ring, corners, band, twist, okay. So these are the various components that are for our discussion. So now let us start with the description about the point, okay, that is related to the microwave component. So in the last lecture, we learned about the component which is known as the E plane T. Okay, so now you can see that this is the E plane T, and this E plane T having the two arms which I said, it's a port number 1, port number 2 and port number 3. This is known as the E arm, and we have derived the S matrix for this component. Now in the today's lecture, we will learn about the discussion of the H plane T. Now this H plane T that consists of the port number 1 and the port number 2. This is nothing but the port number 3. This two arm, they are known as the collinear arm, and it is known as the side arm. Okay, this side arm which is known as the H arm. Why it is known as the H arm? Because this H arm that is parallel to this collinear arm, and this is in the side of the magnetic field. So this is known as what? The H arm. Okay. So now we need to understand about this H plane in detail. So now the H plane T diagram, you can see over here that the port number 1, port number 2, and this is what? Port number 3, and it is known as the H plane T. It is the H arm connected in parallel, that is why it is known as the shunt T. E plane is known as the series T. This is known as the shunt T, mean a waveguide T in which the axis of the side arm is shunting in the E field or parallel to the H field of the main guide. Okay, so that is why it is the component. Now here you can see in this diagram that the port 1 and port 3, they are known as the collinear arm, and the port 2 over here I have named, it is known as the side arm, and it is in parallel with the collinear arm, and that is why it is known as the H plane T. What is the rule for how it works? So if the two input waves are fed to the port number 1 and the port number 2 of a collinear arm, then the output wave will be from the port number 3 will be additive and in phase. Okay, so port number 1, port number 2. If you are applying the input from both sides at the port number 3, you have the output that is in phase and the additive. So this we have to keep in the mind about the H plane T. Now instead of applying the input from the port number 1 and port number 2, if you are applying the input from the port number 3, now what happened in case of the E plane? I told you that when you are applying the input from the port number 3, you have the port number 1 and port number 2, there is the output. That output, that is having the equal magnitude, the same magnitude, but in case of the E plane T, they were out of phase. But in case of the H plane T, what you can keep in mind, if you are feeding the input from the port number 3, Okay, input from the port number 3. You have output at the port number 1 and the port number 2. They are in phase and having the same magnitude. So this is about the thing that we have to use while we are deriving the S matrix for this. So one parameter for the S parameter that we know, that if I am applying the input from the port number 3, I am having the output at the port number 1 and the port number 2 is same. So what I can say over here I can say that S13 is equal to S23. What does this mean? You are applying the input from the port number 3. Okay, so you are getting the output at the port number 2 and the port number 1. Both are same. So one parameter is fixed. That is the S13 is equal to what? So S23. Okay, so now we are going to derive the S matrix for the H plane T. So now you can see that first thing I told you last time, the S matrix of the n by n. So I am having the S matrix S11, S12, S13, S21, S22, S23, S31, S32, S33. So now these things, okay, that is according to the property of the S matrix, that it's the n by n matrix. Now then the second thing, that is, we know that S matrix property, symmetry property, Sij is equal to Sji. Okay, so here we have the scattering coefficients S13 and S23 are equal. Okay, and here as the junction is symmetrical in phase. Okay, so now from this property we may write about it, that is S12 is equal to S21. Okay, S23 is equal to S32 and S13 is equal to S31. So now again you know that while you will match with the perfect load. Okay, so now this is what I said last time, it's the magic T. Fine, it's the matching load. So what I can do, that if I match this with the perfect load, okay, so what we can say that, okay, if you are applying any input and there is no output through that terminal, so while your port is perfectly matched with the particular component, okay, so for that match load, okay, S33 is equal to 0. Okay, so this way you can write over here, it is my S33 equal to 0. So now we are putting all the value in the equation number 2. Okay, so what we will have, S11, S11, S12 is S12, S13 is S13. Now what is S21? According to the property, you can say that the S21 is S12. So here you can see that in the equation which I put, okay, S12, okay, S22, S23 is S13, because you are applying the input from the port number 3. The equal output is available at the port number 1 and the port number 2. Okay, so you can have the S33 is equal to 0. Okay, so now we are putting all the values inside the equation. Now this matrix I have, it is this. Now the S matrix, okay, again you can have the conjugate property. Okay, so it is what, the S multiplied by the conjugate of S is what, it is the identity matrix. So now I put all the values over here and I need to now simplify my equation. That is solving this matrix equation by considering the specific row and the specific column. Okay, we can find it out. So now here you can see that by using, okay, the equation. Okay, so now what happened? R1C1, okay, that is what? So S11 square, S11 complex conjugate of that, S12 into S12 complex conjugate of that, and S13, this is equal to 1. First row, first column, okay, we are taking. Fine. So this way we have R1C1 value, we have R2C2 value, R3C3, value. So now by solving this all the equations, we can have the value for the S11, S12, S13. Okay. So now we are putting all the values in the equation and now solving this all equations. Okay. What I have the value, okay, for the S. Okay. So this way we can find it out the values, okay, for the S matrix of the H plane T. Okay. So this way the H plane T, okay, that can be used, okay, in the transmission of the microwave power. Okay, so this is about the H plane T. Okay, so now we need to learn about the next component. This next component, it's a magic T. So this component, it is the magic T. It is the EHT. It is also known as. It's a combination of E plane T and H plane T. Okay. So now here you can see that this is what? This is my H plane T. Okay. So this is my H plane T over here. Again, you can see that this is what? It is the E plane T. So you can see over here that by the use of all two component, okay, this is we have the E plane T and the H plane T combination. So what is this? This component is a magic T which consists of the E plane and the H plane. Okay, you know that H plane, that is what? It is shunted to this collinear arm. Okay, this is the E plane which is in series with the collinear arm. Okay, so this is having the function of the E plane T and H plane T both. Now as you know that we have studied about the E plane T and H plane T in detail. Now here from the diagram it is drawn, you can see carefully arm number 1 and arm number 2. Okay, they are the collinear arm. And arm number P and arm number S, you can see that are known as the side arm. Arm number P, that's your E arm. And arm number S is your H arm. Okay, so parallel to the electric field and it is thus is magnetic field. Okay, so this way there are how many ports? From this you can see over here, you can see also this port number 1, port number 2, port number 3 and port number 4. So this is the 4 port devices. So now you know that whenever the 4 port devices is there, I need to write the matrix of the 4 by 4. Okay, so it's a combination of E plane T and H plane T. This is the another view, okay, of the magic T. Port 1, port 2, port 3, that's your H arm, and port 4, that is my E arm. Okay, so now the characteristics of this magic T, it's a okay, if a signal of equal phase and amplitude that is sent to the port 1 and port 2. Okay, port 1 and port 2. Okay, what happened to the port number 4? So, port number 4, that is what? Port number 4 is 0. Okay, and if you are applying at the port number 1 and port number 2, output at the port number 3 will be additive of both port number 1 and port number 2. Okay, so this way you can keep in mind if a signal is sent to the port number 4, okay, if the signal that you are applying from the port number 4, the power is divided. Okay, if you are applying, now you can consider port number 4, okay, port number 4, sometimes the ports are different, okay, but you have to consider that in the H plane T, what happened, that if you are applying the input from this H arm equally, okay, equal phase and same magnitude output you are getting at the port number 1 and the port number 2. So here the output we are getting, it's a additive from the H plane T. Okay, so if the signal is sent to the port number 4, the power is divided between the port number 1 and port number 2 equally. But in the opposite phase, over here, there is no output. Okay, so you can write the S parameter value for that. Okay, S34 is equal to 0. Meanwhile, you are applying the input at the port number 4. Okay, so if you are applying the input from this port number 4, you don't have any output at the port number 3. When you are applying the input from the H arm, there is no output at the E arm. If you are applying the input at the HE arm, there is no output at the H arm. Okay, so now this way, if a signal is fed to the port number 3, then power is divided between the 1 and 2. Okay, and there would be no output at the port number 4. Okay, so again, if you are applying the input at the port number 3, at the port number 4, there is no output. And if a signal is fed, okay, at the collinear arms, when you are applying the input from the port number 1 and the port number 2, okay, then what happened? That there is a output, okay, at the E arm that produces the phase delay, and the H output that is the phase in advance. Okay, so S12, S21, okay, both is equal to 0. Okay, so now we will do the analysis of this. So you can see here, if a 4 by 4 matrix, okay, it is here, second from the H plane T, S23 is equal to S13. When you are applying the input from the port number 3, this is your which arm? It is the, if you will see this carefully, this is my H arm. H arm, okay, I am applying the input from this my port number 3, okay, port number 3. So output at the port number 1 and the port number 2, both are equal. I mean, you know that in the E plane T, if I am applying the input from the port number 4, I am having the output at the port number 1 and port number 2. They are same in magnitude, but the phase delay, that is the 180 degree. Okay, so it is the S24 is equal to minus S14. So now again another thing is, you are applying the input from the port number 3. The output at the port number 1 is 0. Applying the input from the port number 4, output at the port number 3 is 0. Okay, so that is why S34 is equal to S43 equal to 0. Symmetric condition, symmetric matrix, Sij is equal to Sji. So again the symmetric property we are applying over here. and you can say that S12 is equal to S21, S31 is equal to S14, okay, S41, okay, S23 is equal to S32, and S42, S34 is equal to S43, okay. So this way, now we have all the values, okay, for the parameters, okay, and now we will put all the values in the matrix. So now you can see over here, if the ports 3 and 4 are perfectly matched, if it is perfectly matched, there is no outcome from that particular port. So you can say that the S33 is equal to S44 is equal to 0. Okay. And now putting all the values in the equation, you can have the equation number 7. That's a matrix, okay, and which consists of all the values that we have found out by finding out the functioning of the H plane T, E plane T, and the magic T. Okay, so now you can see that here I am having the output, okay, in my equation number 7. Now, which property? The complex conjugate, unitary property of the S matrix. So, unitary property of the S matrix. Okay, S multiplied by the conjugate of the S is what? It's a unitary. Okay, it's 1. So by comparing this two value, what I can do? I can find it out my S11, S12 and my all S coefficient, the scattering coefficients by solving the equation. Okay, simple logic of solving the matrix. Okay, so R1C1 here we have written the R2C2, okay, R3C3 and R4C4. Okay, so this way you can solve it, and after solving that equation, here I have the values for all the component. S13 is 1 by root 2, S14 is 1 by root 2, then we have the S11 is equal to S22, okay, and we can have all these values. So now we are putting all the values inside the equation. So in the Vivas, the question can be asked, what is the S matrix for the magic T? What is the behavior of the magic T? You can easily say that the behavior of the component after watching this particular matrix. That S110, mean applying the input from the port number 1, output at the port number 1 is 0. Fine, if it is perfectly matched. Okay, then 1/2, which is this element S13. If you are applying the input at the port number 3, okay, at the port number 3 if you are applying, you have the output at the port number 1 is half, because it is dividing the power. The power is applying at this point, and this point the power is divided. So half of the power that I am getting. So if I am having the idea about the S matrix of any component, I can tell it about the behavior of any component. Okay, so this way over here we can have the component, okay, that is the magic T, okay, and here you can see that the magic T over here, applications of the magic T, that is the multiplexing, duplexing, impedance measurements, radar transmitters. Okay, so this way the magic T that is used in many applications. Okay, and here the one of the applications in the diagram I have shown, it is the port number 1, port number 2. Okay, when the power is fed, okay, from the port number 1, okay, port number 2 to it is transmitted via the antenna. This is the transmitter 3, okay, and over here you can see that the transmitter 2. So this way, okay, the magic T that is used in many applications to transmit the power in case of the microwave devices. So thank you very much everyone. In the next lecture, we will learn about the few other microwave components in detail.